My name is Sarah Ash. For the final project, I created autopsy plugins. So first I'm going to show you how to install those, run them, and go over the code, a little bit about the development process, and challenges I faced. So go ahead and bring up autopsy. I have 3.1.3 on Windows. So you'll need to have an existing case or create a case. So the first thing, you'll go to Tools, Python Plugins, and that'll show you the location that any custom modules will need to be placed. Okay, so I'm going to go ahead and put my device history zip file in there and extract it. Okay, so it's important that under Python modules there is a subdirectory. It won't work otherwise if your modules are just in the top level directory. So this is the package I provided for the final. So we can close this case. So I made two modules, an ingest and a report module, and the ingest module only works when you're creating a new case or adding a new data source. So we'll go ahead and create a new case. So this is the Joe case, and it's listed in the PDF that goes along with this video. So you can select all the ingest modules. I only have my USB device history module selected. So you can see at the bottom it's giving status on the USB device history ingest module. So it's finished the data source ingest, and now it's doing the file source ingest. So this ingest module will tag registry files, the system and end-user registry, and also set up API logs that are of interest in examining USB devices. They may not necessarily have USB information in them, but the ingest module simply looks for these certain files and validates that they're really registry and API log files. So we have 6 files, so we know that there's things to look at. So next we can generate a report, and I'll select the USB device history report module. And that's going to create 2 files, a text file and a CSV file. So if we go to reports, we'll see those reports here. So the text file shows 3 different USB devices, has the vendor, the model, version, the serial number, the vendor ID, product ID, a parent ID prefix, a GUID, a drive if that information is available, when it was first installed, the last connection time, and when it was mounted, and from which NT user registry. So this gives you an idea of which user was using the USB device. So we have 3 items there. And the CSV file, it's comma separated file, so that has the title, the header, and then the 3 entries. So I'll go through the other examples. So I did find autopsy to be slow. I don't know if that's because I downloaded the 32-bit version, because everything's running on Java Python, or the Windows VM, but it is a little slow. So here it is ingesting the module. So it found 6 files. We can generate the report. So this report shows 1 USB device, and this one is correlated to a drive. So it was last on drive E. So as part of development, I made a USB module, and I'll go over that more in detail. But one thing you can do with this is the ingest module identifies the files that you would need for USB analysis. So you can extract those. So that'll make an export folder, or you can put it wherever you want to put it, and save those. So then you can run different tools on those if you would like. I have an offline tool that uses my USB registry module, so I can run that. And I apologize, the font is really small. So you provide it the directory with the files. Oh, I'm in the wrong directory. So that'll show you the same thing as what we saw in the report earlier. So you can extract the files and run your own analysis on them, or you can exercise my USB registry module outside of the autopsy report plugin. So this case, the chart case that we did on week 1, is an example where you have the registry files, but there's no USB serial number in the system hive, no USB store enum. So while it identifies files, it ends up not being able to provide any results. The algorithms I used all are keyed off the USB serial number. So we do have the files, but then when you generate a report, it's basically empty. So it tells you that it could not analyze the device history. And there'll just be a header line for the CSV, no data rows. I had trouble finding all the 3 images we've done earlier are XP images. I had trouble finding a Windows 8 or newer Windows versions. So I made one, but it is kind of a fake image. I extracted the files of interest and kind of kludged together a disk image using the Mac disk utility. But I did want to make sure it would work on a newer version. Let's see. Oh, that's right. Let's see. So you have to go to all files and then it'll show up. And it does seem to work, even though perhaps it's not a format it usually receives. So there it is, processing. And this was useful. The setup API log has a different first line. The vendor ID, product ID, capitalizations were different. So I did update the modules a little bit, made everything lowercase before comparing strings. So it was useful for testing. So unfortunately, I don't have a Vista image or a Windows 7 image to test. So while that's working, I can show you a little about the modules. So as you run, Autopsy converts everything with Jython, so you'll see these class files get created. So at the core of what I've created is a USB registry module. So this creates a couple classes. You have a USB device class, which is just kind of a container. And we have the registry class, which is processing all the algorithms. So the algorithms I got from a few different sources. They're kind of, manually what you would have to do to process the files. So the first method you need to call is to process the system registry file. And that's because the first thing it does is finds the serial number for each USB device in the enum USB store registry, or control set enum USB store. So I put comments for each part of the algorithm. It's kind of a cut and paste from the website, and I have the websites referenced here so you can see the exact algorithms I've implemented. So it gathers the serial number and also the model and version from the registry. So for the low-level registry items, I did not create the logic to parse the binary registry files. I used an open source module to do that. And the autopsy lets you use modules. You just have to place them in subdirectories. So this is code I did not write. It was open source code provided by Will Ballanthan. But it's really nice because it just takes a file with a read method and you tell it, which key you're interested in. You can iterate over keys and values. So it was very easy to use. And it takes care of the low-level stuff. So I was able to focus on the algorithm and integrating with the autopsy framework. So after we have the serial number, we can use that, if it's already a serial number that's in the dictionary, we can use that to correlate with other information. So we look at enum USB, that provides the vendor ID and product ID. And then also the last connection time when that serial number was written to the enum USB. And then we look at control device classes, and that has fixed GUIDs for disks and volumes. So we look for those, and then we try to match it to our USB serial numbers we've already found. And if we find it, then that is another method for getting a last connection time. So getting the last connection times, there was two different methods for doing that. And I just used the later of the last greatest value of the last connection time. And then mounted devices. So here we can use the serial number or the parent ID prefix. So I guess I should back up. You can get the parent ID prefix from the USB store. It may or may not be there. I did not see it for Windows 8, but I had a very limited sample set. And then from the devices, if it exists, you can get the drive. But that can be overwritten. Maybe another device is connected to that drive, so it's no longer associated with your USB device. So it may or may not be there. So after you process the system registry, you can process the NT user registry, and that gives you mount points and also gives you a clue to which user was using the actual device. And then the last thing we can process is the setup API log. And that's just an ASCII log. It tells you when the device was first installed. So again, that may or may not be available, that information. So the key is getting the serial number, and then from there you can grab the rest of the data. Okay, so it looks like our ingest finished. Go ahead and run the report. So that was the USB Registry module. And then Test USB Registry is really just an offline tool. As you can see, autopsy is very slow, so this really helped in development to have this. And all it does is you just point it to a directory, it looks for files, assumes that they're the right type, and then it calls the module process of system registry, NT user registry, setup API log, and then it just prints out the results. So it's similar to the report module, but kind of bare bones just to test the module. So then I have the ingest module. So for the ingest and report module, autopsy, Brian Carrier has samples, templates. So I started with those. And it has to-do statements, things you should replace. So you have your factory and then your ingest module. So these all had to-dos and I replaced those. And in the meat of the ingest module is the process method. And all I do is look for files of interest. So this is a file ingest as opposed to a data ingest because I'm not looking through all the files. I'm just picking out files with certain names. And once I have those, I'm updating the progress bar as we go. But once I have those files, really, I just process them to kind of validate, like, yeah, these are registry files. This doesn't throw an exception. Yes, this is a setup API log. For XP, it says setup API, or Windows 8 says device install log. So just a quick validation that they're just not a file named system, but they're actually the right kind of files. And then from there, I just simply assign them the artifact of an interesting file hit, and then I give it a unique name, which is USB device history. I had hoped to do more with the attributes and artifacts. The Java API tells you can create artifacts, but that didn't really hold up for Python. I got through some stumbling blocks, but I could never get the attribute in the report module to be the right thing. So I couldn't say, oh, this is a serial number. It came out as some other completely different name in the report module. So unfortunately, I couldn't do what I wanted to do with artifacts and attributes. But the ingest module identified the files, which I think is useful for extraction if you want to run your own tools. And then the report module is doing most of the work. So here is the report module. So in generate report, it is going through and looking for anything tagged as the interesting file, and then it checks the attribute set name to see if it's a USB device history. So it gathers the files identified by the ingest module. And they've already been validated by the ingest module. So once I get the name, I just process them, for system files, NT user, and API. So I gather those lists and then I process them using the USB Registry module we went over earlier. So once I process all those things, I create the text report. And I'm simply using the USB dictionary that's in the USB Registry module to print out information. Then I add the report and close it. And then I do the same thing for the CSV. Just iterate over the dictionary. Okay, so it looks like this report finished. So we have one USB entry. There is no install time for this one, but it does show that you can process a Windows 8 image. Okay. And the last module that I created was file like. So it's very basic, and it's only used in autopsy. So the registry module, which I used, was expecting a read method for the registry file you gave it. It either expected a file path or a file-like object that supported the read method. Unfortunately, the content object that is returned by the autopsy framework doesn't have a read method. You can do the read content input stream on the content, but of course the registry module wouldn't know about that. So this is kind of a adapter class to get the two interfaces to work with one another. And in the sample ingest code, there was, how to access the Jython array, put that into a buffer. So I just modified that code so that the read method would work with the registry module. And then also I made read lines because I found that useful in my code to be able to just call read lines. And there's also a new module, which is, you can just download it. It's part of Python 2.7. And that was used by the registry module. So I just had to have that as part of the package, the zip file. So that's all the source code. So like I said, some challenges were that it was kind of slow, but I found having, putting most of my code in a regular Python module and testing that offline was really helpful. Another challenge was the attributes, which I discussed. I wasn't able to use all the API that you could use, I think, if you're writing a NetBeans plugin. I did find something unique to, testing. I didn't find it just testing outside of autopsy, outside of Jython. I was getting a weird error on the parent ID prefix. So offline it was working just fine. But in autopsy I kept getting these registry exceptions, and it turned out the ASCII characters were somehow becoming 2 bytes and being flipped. So the most significant byte had the ASCII data, and then the second byte was just all zeros. So I just kind of put in a quick test so it could work for, in autopsy and outside of autopsy, to just test, if it's greater than, if it's in the MSB, then it needs to be shifted. And that seems to work. So I don't know if that's a Jython bug or some interplay between Jython and the registry module. But that took me a while to track down. And I also never got logging to work. That's supposed to be a development tool to be able to log things, because you don't really have access, to like a print statement like as you would in normal Python development. But that did not work for me. But luckily this, I think I temporarily passed a handle to the report module and printed out to the report module what these values were. So I kind of used that for debugging. But it would have been nice to use the log module. And there are examples. You can create your own module. I can show you just as normal development, if you make mistakes, like you make a syntax error, leave off a parentheses, and then if we run this report again, it'll give you an error right away if it's a syntax, the line number and where the error is. So that's kind of nice that the tool, regenerates for the most part the Jython conversion each time. So put that back. And then if you do something less obvious, like misspell a method name, it'll give you a runtime error. So it does give you some feedback. So unless it's here it is. So there's that data. So it does give you some feedback. And maybe you can get the logging to work, or cheat and use the report module like I did. The framework is well documented, so that was nice. But like I said, it may work in Java, but not in Python. But I think I learned a lot about the tool. Extracting files seems very useful. I think I could make my own custom ingest module, report modules if I was analyzing a specific case. So that's my final project. I hope you learned something from that, and I know I learned a lot doing the project. Thank you very much.